For as long as human beings have wandered the earth, we have been transfixed by the night sky, a sky that seemed timeless, tranquil, and unfathomably remote. I'm Patrick Stewart. At the beginning of the space age, from our new vantage point above the Earth, we glimpsed an unexpected universe, a place of thrilling change and tremendous violence. Surprisingly, we discovered that this unexpected universe is less remote than the serene place we used to know. We also discovered that we belong to our violent universe. We're not only made of the same stuff as stars, the atoms in our bodies are actually made by stars. The discovery of the violent universe could be the most earth-shaking contribution of the space age to science.
This first movie made in space was filmed just after World War II. We were excited by this new view of our planet, but we would be astonished when we looked in the other direction, toward space. Our picture of the universe would be turned on its head. An early discovery of the space age took place in a remote part of the Pacific.
Making music on tin cans and dancing for us. You think they were good dancers, Jed? No, huh? Can you dance that way?
Yeah.
To the rock.
Herb Friedman is an explorer. So these are no ordinary home movies he's showing to his grandchildren. It's a record of a trip to the Danger Island, a scientific expedition that changed our understanding of the sun.
These men came from the University of Wisconsin.
What year was
This was 1958, more than 30 years ago.
Dr. Friedman went to the South Pacific to lead the first rocket study of a total solar eclipse. The eyes of the world were on this expedition. Globe-trotting newsman Lowell Thomas was there.
High Adventure with Lowell Thomas. Why Danger Island? Why a lost pinpoint in the vastness of the Pacific Ocean? And what will these instruments tell us about the source of all energy on our Earth? About the solar atmosphere? About deadly cosmic rays? That night, the Radio Shack sends out a last report, listened to throughout the world. Eyes UI expedition on Puka Puka reporting. Rockets armed. Preparations for solar photography complete. Eclipse will occur at 0830 tomorrow morning. Dr. Friedman talks to the men below decks at the rocket control panel.
All hands take cover. 1 minute till firing time.
Mark. 3, 2, 1, 0. She's on her way, and in 4 minutes, she'll be 150 miles up. We leave the South Pacific believing that we may possibly have witnessed one of the most important events in the history of man, the dawn of rocket astronomy.
Friedman discovered surprising sources of high-energy light. His bigger achievement may have been to prove that precision science could be done from rockets.
Look at it.
Friedman first worked with rockets at White Sands, New Mexico, a decade before his eclipse experiment. Here, the U.S. tested captured German V-2 missiles. The V-2 was balanced to fly with a ton of explosives in its nose cone. In early test flights, concrete or steel took the place of the bomb. Then someone had the bright idea that scientific instruments would be a more productive ballast. Science became a stowaway on a military vehicle. This ungainly machine would give us our first peek at the universe beyond the veil of the atmosphere. Loading the instruments was the easy part. The film data cassettes had to be retrieved after a 100-mile flight into space.
Thought was that when the rocket crashed, you could dig around in the debris and find these cassettes and recover the film, develop it, and have your information. In the first attempt, the rocket was allowed to come down in streamlined flight and buried itself in a crater some 80 feet wide, 40 feet deep. It was almost impossible to recognize anything in that debris.
Friedman worked out a better solution. Why not transmit the data back to Earth before the rocket crashed? Telemetry was a breakthrough, allowing Friedman to get out of the salvage business and focus on scientific discovery.
The rocket launch, of course, is a great big fireworks show. And then you wait, not very long, watch the telemetry, and suddenly you see the answers coming in. And you fix on that TV monitor, and you're almost out of this world seeing your experiment talk to you from 100 miles up.
Before rockets, Earth-bound telescopes had shown us only this face of the sun. This is how we see the sun today, from space, in X-ray light. No one expected that Friedman's experiment, with its first ever detection of X-rays from the sun, would mark the birth of a new astronomy. X-rays are a kind of light, part of the electromagnetic spectrum, which includes the rainbow of colors we can see. The spectrum ranges from radio waves through microwaves and visible light onto high-energy X-rays and even higher-energy gamma rays. Of all these varieties of light, most are screened by the atmosphere. From our sheltered vantage point on the Earth, we have only a narrow view of the cosmos. In the early 60s, gamma rays were only seen in nuclear explosions and physics labs. The US wanted to make sure the Soviets obeyed a nuclear treaty. The best approach: scan the skies for the telltale gamma rays of illegal nuclear explosions.
Fire!
The first of a series of secret military satellites was launched from Cape Canaveral in 1963. The Vela orbiters would keep a vigil for high-altitude nuclear explosions. The Vela satellites began to detect blasts of gamma-ray light. The signals didn't match the profile of a nuclear explosion in space. Scientists tried to imagine how a small object brighter than the sun could switch on and off in a flash.
You have to create an object which is a few hundred kilometers in size and yet can radiate a million times the energy that the sun radiates, and crank it up in a fraction of a millisecond and then disappear. I don't know how you do that. I don't know what kind of object that is.
The Vela satellites never actually detected an illegal nuclear test. Instead, they discovered the jolts of high-energy light, now called gamma-ray bursts.
No one ever, in his wildest imagination, ever thought that there was such a phenomenon. I mean, they were not put there to discover gamma ray bursts. They were put there to look for nuclear explosions. And it was just a classical case of serendipity, of a detector that was designed to see a specific kind of phenomena, and it turned out that nature made that particular kind of phenomena, and we didn't know it.
By chance, the Vela satellites uncovered celestial events we would never have dreamt of seeking.